Hello friends, if you look at this program in the first go, it might seem to be very simple. Well, what I did over here, you will think that over here you have got a couple of variables. You can think it because you might be coming from the background of C, C++, Java. But Python presentation is slightly different. What is that? Are these not variables? Well, whether it's a variable or not, let's illustrate this through this particular diagram. What the beauty of this diagram? This is considered to be a variable like what we see over here, but the problem is this variable is not holding any data. Wait, what I'm saying, you have got x assigned to 10 or 10 been assigned to x. Well, it is true, but internally something is different. And what is that? X is holding an identity of an object, and that object holds the value 10. What do I say? I say that y is holding an ID of an object, and that object is holding a value 20. How is that working? Yes, that's how it works. If you want to perform a sum of two numbers, you can do that, no problem. But if you see over here, I've written this one, identity of x and y, is it same? The answer is no, it's not same. It's not same. Well, let's run the code. Okay, let's run the code now. So Python space, the file name is intro underscore pvm.py. Let's hit the enter. Okay, it's showing the entire stuff. What I will do is that let me clear the screen first and let me comment this portion. I will come to this part a little later on. Let's keep it like this. And now let's run the code once again to see what is happening. Well, it's straightforward. You are doing the sum of two numbers, nothing wrong in that. And then comes identity of x and y. There is a keyword called is, and the is saying that it's not true, it's false. So identity means x holds an identity of an object, and that object has an address, or better to say it has got some identity rather saying address. The best way to represent would be it has an identity. Well, you might be thinking like identity, address, are they not same? Well, not exactly. Let me give a small example. Like I have got my own Aadhaar number, right? So that's the identity of mine. But do that Aadhaar number put forward my address? Where do I stay? Absolutely no. Same goes for you also. You have been given an Aadhaar number by the government of India or a PAN number by government of India. But does that PAN number or does that Aadhaar number implies where do you stay? Or is it an address? Aadhaar number is an address. No, it's not an address. Exactly the same thing is happening over here. So this ID is been generated by Python virtual machine. Well, I use the word virtual machine. Yeah, Python has also got a virtual machine. We'll see even that also in this video only. So it is generating an ID where this particular object is residing. So it is the object that holds the value 10, or it is the object that holds the value 20, and that's what you are seeing right over here with the help of the function called ID, identity of an object. So when I'm giving a call to ID within bracket x, so it is showing what x is actually holding. It is holding an address. It is holding an address, and that address is actually holding the value 10, as you saw in the diagram. So x is actually pointing to an object, and that object has got one ID, and that ID or that object is holding the value 10. Same goes for y. Y is referring to an ID of an object, and that object is holding the value 20. And that's how it differs from traditional C, C++ or Java, because those are not being represented object over there. They just have a variable and that has the data within itself. But in case of Python, you must keep it in mind that these are also an object, and that's the reason why it is called Python everything is an object. What does the meaning of that line when people say Python everything is an object? What it means is that x is referring to an object, and that object holding the data, and that's the reason why we call it an ID. So ID within bracket x means X is holding an object, the identity of an object is what getting exposed over here. So both are different, right? So far so good, isn't it? Now slightly make some change, and then the interesting part of the story evolve. What if these two objects have the same value? What happened this time? Well, I again go for the same thing to check whether it is true or false, and I will be seeing that ID again. Alright? Well, if it is C or C plus Java, of course these two are two separate variables, but does it really happen the same in case of Python as well? Well, if you look at the image, you will find that X and Y are both point to same memory location. Same object. Again, actually, we often use the word ID in context to, like, by default it gets mixed with the address, but to be sure, it's not an address, it's actually the ID of an object. So it's pointing to the same object and it has the same ID. This is something really special about Python. Okay, so let me run the code again, and this time let's see what happened. Let me clear the screen and let's execute the program, and bingo, we see something really amazing. What is saying? It's saying that identity of 20 and 20 is true. Why is so? Because both X and Y is referring to the same object. The reason why you get to see both the address same, and that's what I demonstrate in the image as well. The moment you have got same value, they are not going to point to two different objects, rather they will be pointing to one object, and that's the reason why they will be having one ID, and that's the reason why it is showing true right over here. But imagine if this was C or C plus Java, thing would have been different over there, isn't it? It would have been two different memory locations, but that's not the case in context of Python. So remember, everything in Python is object. When people says that, actually behind the scene they're talking about this entire thing, that when you have two different variable, they are actually not holding the value, rather they are holding the reference or the identity of the objects. And when they have got same value, then they will be having one common object, and that's what got generated right over here. I believe you can figure out now how exactly C, C++, Java at one hand with that of Python at other hand, how they're different, right? Okay, don't worry, in upcoming days I will be showing much more, some amazing facts about Python that makes Python so special. Now we know that every high level language needs to be compiled and it will generate a machine level language, but if you notice over here, do you see anything apart from this .py file which I'm executing over here? Of course not. So you might be wondering that in case of Python, maybe you don't need the machine learning code or it doesn't create any bytecode, right? But that really doesn't happen. Well, actually here also the bytecode gets generated, but it happens internally. As a result, we won't be able to see it, and that's the reason why we are not seeing, and we are having an assumption that provide these things is not happening over there. There is no bytecode generated. In fact, that's not true. Bytecode is generated, but that happens internally, which is not visible to us. But wait, would you like to see the bytecode? Okay, I understand. So remember, previously when I executed, I was giving a call to my file directly, right? And that's the way it was executing, and I was not seeing any bytecode right over here. And that's the way it happens. But now I would do a small difference. What happened this time? Well, if you notice over here, I've written a comment line -m. I'm giving a special call to a module called compile all. So what I will be writing over here is Python space -m, and then I will go for compile all. This is a special module. I will give a call, and then I will give a call to my file name that is called intro._pvm python virtual machine.py. Now before I hit the enter, please take a notice over here that I'm inside this particular folder called basic, and currently it has just got only one file, the file which is in front of you wide open, which I was working on so long. Now if I hit the enter, you will find something very interesting. __ PyCache folder will get generated right over here. See, __ PyCache _ folder got generated. And you must be wondering, what the heck is this? Well, it has got a special file. Let me expose this folder, and it has got a special file. Look at the file name. How big is the file name? No, it's not a big. Actually, it has a first my initial file name intro_pvm is there, Now it is showing C Python, and it is showing the version which I am using. So 3.12 version I am using. In short, it is showing like 312. It's like 312. It's not like that. You should read it as a Python version. So C Python I am using, and the version is 3.12. Is put together as 312. And .pyc file, that's a compiled file which is now in the form of bytecode. Well, can I run this particular file now? Well, that's what is the topic of discussion now. Yes, this time I will not give the call to this particular file directly. Rather, I will say python space, what is the folder name, underscore pycache. So underscore pycache. I am not typing, pressing the tab from the keyboard. The entire folder comes in with a slash followed by this particular file name. Now I have to type, that is called intro. Again, I will press a tab and the whole file name comes over here. So it is very clear that I am not giving a call to this file, rather I am giving a call to this particular file, which is my bytecode, and I am very sure you didn't see this very frequently, right? Okay, great. Now I hit the enter. Once I do that, you see exactly the same source code, I mean the same output of the same source code which you saw previously when I was giving the call to this. And this is what the beauty of Python. That means compilation was happening even previously also, but that was happening behind the scene. And now you saw with the help of this particular module compile all, everything is in front of you, and that's how the bytecode got generated, and that's how you get to see the identity of these objects. So when it is having a same value, it will point to the same object, and when it is having different value, it will have a different ID for the different object. Okay, so that was a small video, and I believe that was a really very interesting video. I really love talking about this particular topic. Well, in my upcoming videos I will be saying much more internal details about Python, which you will enjoy a lot. Okay, until then, have a nice time. Bye bye, take care.